Go16 Applications webinar. We're very happy this week to have Brian Carcione, the SU at the Huntsville office in Alabama, the one that is co-located with Sport. And he's going to be talking a little bit about some observations from the geostationary lightning mapper and from lightning mapping arrays, because both of those data sources give you information about lightning. Just a few housekeeping things first. Brian, if you want to go to the next screen. This is part of the FDTD library. There's some there. We're always looking for topics. So if you have something you want to talk to that you've seen in the office recently using Go16 data that you think would be of general interest, send either me, Scott Lindstrom, an email, or one to Dan Bykos. And you can see these recordings. These are all recorded, so if you've missed one, you can do a Google search on Visit Satellite Chat and you'll find them. Next screen, please. Just some logistics. We'll have about 20 minutes or less for Brian to talk. If you have questions, you can send them on the webinar Go to chat, or you can ask the question and answer after Brian's talk. Don't press hold, and mute your phone when not talking. And with that, take it away, Brian, and thanks.
All right, thank you very much, and I appreciate the opportunity to speak today. I really want to give a lot of credit to Jeffrey Stano, who's in the room here with me. He's the Geostationary Lightning Mapper satellite liaison, and you'll see in a moment that he had a lot to do with getting this presentation put together, as well as Chris White, who's the Weather Service Sport liaison, and Dick Orwell from Texas A&M. Just a quick review of what we're talking about when we talk about the Geostationary Lightning Mapper. It's the first space-based operationally usable lightning detector. There have been others in the past, but this is the first one that's operationally usable. Conceptually, it's a large digital camera identifying pixel-level changes in brightness to identify those events events make up the groups and then the flashes. Don't forget, this is intra-cloud and cloud-to-ground total lightning, but it doesn't distinguish between the two. For that, we would need a ground-based network. And the instrument sends data every 20 seconds, and as we'll talk about here in a moment, the ALIPS visualization in its current form combines that into 1-minute accumulation images. Just a quick sort of comparison of what we're talking about. Scott made reference to the lightning mapping arrays. So if we have sort of an idealized little thunderstorm here on our cartoon, those emit radiation in the very high frequency band. And so for the lightning mapping arrays, you can put VHF sensars in a very closely spaced format that gets very good location accuracy. It can detect both intra-cloud and cloud-to-ground lightning. But the problem is that you don't have a lot of range. You need a lot of sensors at a very fine resolution to detect it. So if anything gets beyond a certain radius, then you rapidly start to lose access to what's going on. Conversely, the GLM is detecting those optical pulses from the top of the storm. As I mentioned, again, that's intra-cloud and cloud-to-ground lightning, but it doesn't distinguish between the two because it's only seeing those light pulses. But the good news is you don't have that range issue that you have with the ground-based networks. And one kind of interesting thing that I don't think we've seen a lot of yet is that light can be attenuated and scattered by clouds. So to give you some sort of an idea of what that might look like, this is sort of an idealized perspective of a thunderstorm with a lightning flash in progress. So you can kind of imagine that what's going on here in the middle is the main part of the flash, but some of the outer part that might get triggered by the GLM may not be the actual flash itself. So with that, one thing I want to talk about before we really get into this sort of case study, I think when I I think we're all really excited to be looking at GLM, but I think we underestimated just how much was going to be needed to learn about how the GLM was going to work. As I mentioned, this is the first operationally usable lightning sensor, and so it's brand new. There's a lot to learn. There were a lot of things. I think a former defense secretary would call them known unknowns. There were things that they expected to discover and have been working through them, but there were a lot of unknown unknowns where they're still working through some issues. And that affects AWIPS as well. So what I'm about to show is not yet available to us in the NWS, and I caution that the data are preliminary and non-operational, but the visualizations, calling them preliminary and non-operational is almost an understatement. They're still working through some details. So the visualizations I have in this presentation were the very preliminary AWIPS tools provided by NASA Sport, provided by Jeffrey Spano. But I think my understanding is that what I'll show you is pretty far from what ends up getting into AWIPS. And what I'm going to show you is the event density. So those are kind of the pieces of flashes that the GLM picks up, as well as source density for the LMAs. We'll compare the two as we go through the presentation. But this is our attempt to compare apples to apples because they're both sort of pieces of flashes. Okay, so I'll apologize for the loop, and we'll do our best here. I'll loop through this a couple of times. This is a loop of Harvey at landfall, as it's making landfall along the Texas coast north of Corpus Christi. And you have the background image is the ABI data, but then the color-filled imagery is the GLM 15-minute accumulation over time. A couple of things stand out, and I'll loop this a couple of times. A couple of things stand out to me, at least. One of them is the way the eye of Harvey really lights up just as it's making landfall. Right here, north of Corpus Christi. One of the other things is just how electrically active those rain bands, those terrible rain bands, were over Houston. And having talked a couple of times to Lance Wood, the Sioux at the Houston office, he said he was really kind of surprised at how electrically active those bands were over the Houston area. You also see sort of a persistent banding that is initially there over the Lake Charles CWA, but then sort of fades away and then fills back in late in the loop. So I'll loop this one more time. What we're going to do with this presentation, we're going to look at the Houston LMA and the GLM over the Houston area during some of their rainfall, and then we'll also look at the LMA and GLM over Huntsville as the remnants of Harvey came through our area a couple of days later. So here is a loop of the rain bands, and it's just going to loop continuously. So at top left will be the GLM event density. At top right will be the Houston LMA source density, courtesy of the folks at Texas A&M University. Bottom right is the Houston half-degree reflectivity. Bottom left is the CONUS scale ABI imagery for the kind of standard IR. And there are a couple of things that stick out in my mind as I'm watching these. One is that the resolution, the fine-tuned resolution of the LMA versus the GLM stands out a little bit more. I think they compare pretty favorably, but you really do see GLM, the resolution, because we are talking about a geostationary orbit. GLM is operating at an 8-kilometer resolution at nadir. So it compares pretty favorably, but you do see that the LMA since it is that ground-based, closely spaced network, that their resolution is 1 kilometer. So that sort of stands out. But you also get a sense of the varying range in all of this. GLM really gets a sense of some of the convection in the western Gulf near Brownsville that obviously the Houston LMA is far too far away to pick up on. From kind of a meteorological perspective, there are some situations where the cloud tops are warming between Corpus Christi and Houston, yet they continue to produce some total lightning even after the cloud tops are warming. So that I'm not saying that's a statement that's been validated or confirmed in any way, just something that I've kind of noticed looking over this imagery for the last couple of weeks. And again, the eye wall lightning that was present at landfall has now faded now that it's been inland for quite a bit of time. But something else worth noting, the colors in the 15-minute in the long loop that I just showed prior to this show a lot greater flash density, and this is a situation where the amount of time you accumulate the flashes really matters. So that 15-minute accumulation shows these really dramatic changes in ways that the 1-minute imagery won't visualize quite as well, because you're chopping up the data into smaller bits, so to speak. I'll let this loop 1 or 2 times, and certainly if anyone has any other observations that you have, I'm all ears. This is a fairly small subset of the data we gathered, and that was just sort of out of necessity because of how large the files got on the loop side of things. Okay, so some observations. As I said again, that I think they compare very favorably. There are very few cases, at least in the Houston area, where one detected something that the other didn't. I thought they looked very good and very comparable to one another. Now, granted, this was at night, so you would expect the GLM to perform pretty well. There's a real minor difference in the time definition of the files, but that's not an instrument issue. That's just that's a transmission and a file issue. As I mentioned, some differences that stand out: the limited range of the LMA and the resolution of the GLM. Certainly, the most electrically active storms are still in the Gulf of Mexico, and as I mentioned, the cloud tops have warmed, but the lightning continues after the fact. So we'll do another loop here, and again, I'll just kind of let this loop for a little while. This was when the one of the sort of feeder bands moved across the Huntsville County warning area, and again, at top left, you have the GLM event density. At top right, you have the North Alabama Lightning Mapping Array source density, and at bottom right, you have the High Top Alabama half-degree reflectivity. I wasn't able to get the ABI data for this particular case, but there are a couple of things worth noting here. This is obviously smaller scale. You're looking at things a little more zoomed in. For a tropical event, this was fairly electrically active, but in all things considered, these were pretty low flash rates compared to what you might see in just a typical summertime thunderstorm. But there are a couple of things worth noting. Is you have a lot of kind of low flash rate but long flash events. So there are a couple of situations where you see these flashes sort of arcing across multiple counties, and that ends up being relevant for decision support. We do airport weather warnings for the Huntsville International Airport, and the LMA and hopefully someday the GLM played a large role in our decision to issue an airport weather warning for the airport, because there may not have been quite the traditional sort of core of cloud-to-ground data, but there were a lot of these long, low-grade flashes that kept arcing across the 5-mile radius that we use for their airport weather warning decision radius, so to speak. And then something else that's kind of interesting, you may have noticed there's a little uptick in the lightning as one of these storms moves from this kind of triangular-shaped county here, which is called Coleman County, into this sort of oddly shaped county to its northeast, which is called Marshall County. And we actually had an EF2 tornado that occurred in that area. It's interesting to note that the most significant uptick in lightning actually occurs well after the tornado is on the ground. You can sort of see it right here in this time frame, right around 2:15 to 2:20 UTC. There's this uptick in the lightning, and by that point, it's been on the ground already. So I think that sort of illustrates one of the caveats we need to be considering when it comes to total lightning and tornado detection. I mean, we don't expect tropical events to have particularly robust lightning signatures, and this event certainly sort of reinforces that concept. So the lightning is not going to be a panacea for all of our warning decision-making problems necessarily. So again, if you were watching, LMA and GLM, I think, compare very favorably, and the low flash rate, the minor difference in time definitions showed up a little better. There were a couple of these long arcing flashes where it showed up in the GLM and then it showed up in the LMA or vice versa. That's just a simple timing issue that I think won't be a factor moving forward. But the resolution differences do impact the perceived spatial extent, and that may affect IDSS to some extent, but for those of us who haven't had access to LMAs, we'll take what we can get. And as I mentioned, the EF2 tornado did not have a lightning jump prior to tornado genesis in either of these two detection methods. Moving forward, there was a GLM science team meeting here in Huntsville a couple of weeks ago, and they literally spent 3 days talking about calibration and validation. There's still a lot of work that they want to do in that area. As I mentioned, I think what I just showed you is a very preliminary AWIPS visualization, but I know there are a lot of efforts underway to fine-tune that and improve that. So I think what ends up coming out to the field will be better and will be a big improvement. And then obviously, both at the field and in academia, there's going to be a lot of research and training and education, because we have lightning data where it hasn't been before, or where we haven't seen it before, where we haven't measured before. There may be some parallax issues that I think we want to explore. There's some data that we may not have considered before. And then, we know it's going to get incorporated into some of these big data algorithms, so that'll be interesting moving forward. I have two links here to the NASA Sport blog. There's a couple of examples of geostationary lightning mapper data that Jeffrey and some of the sport folks have put together, including the hurricanes. But the second link are to lightning mapping array examples. We've been using lightning mapping arrays here in Huntsville for almost 15 years now, and so if you want to get a feel for some use cases, that's a good place to sort of get a full scope of how we've been using them over the years. And in addition, I really would like to thank Lance Wood at Houston for his insights, as well as the folks at the OPG for some of their insights as well. And with that, I'm done, and I'm happy to take any questions.
Hey, Brian, this is Steve in Tulsa.
Hi, Steve.
Hey, a question about the viewing there in AWIPS. Was that the default plugin, or was that a Huntsville version of the plugin that's viewing that data, 15-minute data?
I think that was a sport sort of iteration of it to view the data in greater accumulation steps. I don't know yet. I don't know that that's going to be, as I mentioned, I don't know that that's going to be something that will be standard, but they were kind of accumulating the data over a longer time step. The color curves and things like that, some of that came from the hazardous weather test bed. So they did they did some evaluations this past spring. So this was sort of what I showed is sort of cobbled together between what was sort of a preliminary version from the AWIPS program and some improvements from the hazardous weather test bed and sport. So that's why I say I think this is calling this preliminary non-operational is almost underselling it a little bit.
Yeah, this is Scott at Sims. I don't think anybody knows what the GLM will actually look like in AWIPS because I don't think that's quite been hammered out yet. So.
This is Jeffrey as well. I'll second what Scott and Brian have been mentioning. Some of the latest I've heard in terms of some of the AWIPS activities that are going on is that we're looking at probably a January or February time frame for some of the initial AWIPS corrections, but we could be going into June 2018 for more extensive updates to AWIPS for the GLM.
I heard something about June 2018.
Well, it sounds like I've lulled everyone to sleep. Any other questions or comments or any other things we can help you with for this talk?
Well, thanks, Brian. This is Scott at Sims again. We do have another FDTD webinar in 2 weeks, so watch your inboxes for that, and I guess that's a wrap.